But look how few sunspots there are when it's at minimum and it's at the equator.
Wait, so sunspots are closer to
I don't know.
the equator?
They're actually still studying it to figure out what happens. Yeah. See how many sunspots there are when they're at the middle latitudes?
And then number 5 is equator?
They're at middle
Correct.
latitudes during solar maximum.
Number 5 is
And they
equator.
close to
See,
the
as it gets closer to the equator, you get smaller and smaller amounts
At solar
of
minimum, there are sometimes no sunspots.
sunspots.
At solar maximum, there can be many at the same time. The number of sunspots is important because sunspots are the visual markers of where powerful magnetic fields have emerged from the sun's interior. These magnetic fields power solar flares and coronal mass ejections, which can...
It's magnetic field.
Magnetic field. Magnetic field, it gets EMP burst through the sun. It can temporarily disrupt our magnetic field on Earth. It can shut down electricity, your cell phone reception. That means no Wi-Fi, no broadband, no nothing. Yeah, I know, right?
No Wi-Fi.
No Wi-Fi. So it's important now, huh? Alright, we're gonna keep going on because I got another
other objects in the solar
demonstration for you guys.
As the sunspots increase, so does the frequency and severity of flares and CMEs. The sun's 11-year cycle is a symptom of a longer 22-year cycle called the solar cycle.
Okay, that's the confusing spot. So the solar cycle is actually 22 years. It's 2 sunspot cycles.
Why?
So that's why it's confusing. You're about to see why. You're about to see why.
Or hail
That's the
cycle.
confusing. See, there's 2 different cycles. There's a sunspot cycle
Solar field.
and the solar cycle.
It's
And
solar.
This is
about
the
to
sun's
say right
magnetic
here.
field. Every 11 years, the sun's poles flip.
Every 11 years, the sun's poles flip.
North becomes south and south becomes
So the north is now
So
in the
every
south.
22 years, the poles return to the position where they started the cycle.
So that's the solar cycle because the north, when 11 years, the north pole went to the south pole, and then 11 years later returned. So it took 22 years for the north pole.
Like, how did we discover that they
Oh, you'll see.
Yeah, how did they discover
The
that?
flip is due to the complex movement of magnetic fields.
The short answer: many genius people spend their entire lives trying to find this stuff out. Many of them fail finding anything out, but some few are successful.
Inside the sun that are constantly stretching, twisting, and crossing as solar material bubbles up from the sun's core. But the exact pattern of movements is not yet mapped out.
Did y'all hear that?
No.
The complex movement of magnetic fields inside the sun that are constantly stretching, twisting, and crossing as solar material bubbles up from the sun's core. But the exact pattern of movements is not yet mapped out.
So we don't even know what really goes on. Like, we got an idea, but we don't know how it actually all works. They're actually sending a satellite up there to observe the sun 24/7, and hopefully it'll give us data so we can better figure out what's actually going on. But to this day, we don't really know. I mean, it's a big ball of gas, burning brightly. How many miles away again? 97 million, I think it was.
It was, 147 million.
Yeah, so it's kind of hard to get data on something that far away.
Because of the sunspot cycle,
What's that? Number 7 was every 11 years the sun pulls flip. Remember?
No, 7. Magnetic field and power solar field.
Solar flares,
Solar flare.
which both reach that. 7 solar flares. The magnetic field and power solar flares.
similar pattern regardless of the
All right, quiet down so
It
your
only takes half as
classmates can
long
hear.
as the solar cycle. The 2 cycles are different, but the 11-year sunspot cycle is often referred to as the solar cycle, which can be a little confusing.
Hear
The
that one
2
more
cycles are
time.
different, but the 11-year sunspot cycle is often referred to as the solar cycle.
See, the sunspot cycle is often referred to as the solar cycle because people aren't used to it. They don't know it.
It's not
That's
giving
new
us the
information.
answer to 11. It is.
Yeah, you should have. So it's wrong. Okay.
Number 10 is not. Number 11?
Huh?
Number 8 is 11.
Number 8 is 22 years cycle. Number 9 is 11 years before full.
Which can be a little confusing.
And then yes, I gave you 11 because I
Right
didn't want there
now,
to be any
the sun is
mistake.
approaching solar maximum, so flares and CMEs are more common than they were a few years ago. This cycle may peak in 2013 or early 2014, and should reach its minimum somewhere predictions about the sun are still uncertain. The slower than expected progress of this sunspot cycle has led some to speculate that the next sunspot cycle might be very minimal, with few sunspots even at solar maximum.
So that dotted line is just their guess. They don't really know. It's still data.
The next
Video's a couple
sunspot
years
cycle
old.
might be very, it is still far too early to know. But even if this is the case, it has happened before and isn't something to worry about. It just means that the sun would briefly be a little closer to the unchanging orb it looks like from the ground.
You need to ask Mr. Ott. He's your teacher right now.
Number 10, wrong. 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 Well, y'all can turn it in whenever y'all line up to leave to, what's it called? Yeah. How long till that happens?
You have about 20 minutes.
I have an extra one.
No, we'll put it back on the table.
Oh, no. Okay, that's fine.
He said when you get ready to go for PE.
Alright, so we're gonna blare through this part because I wanna do my last little thing, demonstration with y'all. So sunspots are sunspots on the sun. They occur over regions of intense magnet activity. It's where energy is released. It's still extremely hot. It's 3,800 Kelvin, and the photosphere is 5,800 Kelvin. So it's still extremely hot. It's just, it looks dim because it's by a much brighter light. Just like the stars that are farther out at night, they look dimmer than the sun, even though they might be 20, 100,000 times bigger than the sun. It's just they're so far away. So what are solar flares? So this is this the type of stuff they need to be writing down for the science journal? The solar flares and all the surfaces?
I mean, you don't have to put it in a journal, but
Okay.
just so they'll know.
Okay. Are intense bursts of X-rays, energy in all directions, and they travel at the speed of light. So the solar flares, they're X-rays. This is one right here. And have y'all done the light spectrum yet? No, y'all haven't. Dang, I thought y'all would have already. Y'all know what's on the other side of what the light y'all can actually see? ROG biz?
Oh, yeah.
Infrared, ultrared, X-rays, microwaves, radio waves. Y'all have done that yet? Okay. So they travel at the speed of light. Corneal mass injections, they're giant cloud particles hurled into space, and they take about 1 to 3 days to reach Earth, and they appear as eruptions from the sun. The one before that was solar flares. How long do you think solar flares takes to reach the Earth if it travels the speed of light?
I'd say about a week. I'd say maybe a year. 10 seconds. No, what was that? A week.
8 minutes.
I
Speed of
was
light.
probably an hour.
So when you stand outside and you feel the heat of the sun hitting you, it left the sun about 8 minutes before it actually felt you feel it on your skin. That's how far the sun is. You know how fast light is. Like you can turn on a light switch. It doesn't take any time at all for it to hit the wall. All the walls in the room does it.
Yeah, it's just like really
instant.
fast.
It's instant.
So, like when I do soccer and all of a sudden it feels a bit hotter, is that because it's like solar flares?
No. Typically because you're getting hotter, that's because your body is getting warmer because you're probably moving or acting, and there's a whole biosphere in yourself. Solar prominences. This is the approximate size of Earth, and this is a solar prominence, so it's huge. It's anchored to the sun's surface in the photosphere. We'll have y'all sheets to show y'all where that's at. It takes about a day for it to actually build itself up, so it's kind of slow when you're comparing it to corneal mass injections and solar flares. And we're still researching how and why these are formed. We don't know. Like I said, we're sending a satellite. Hopefully we'll be able to figure it out. prominence is, who can guess what that is? Erupting prominence. It's basically, it erupts, it gets out, the loop breaks, and it actually goes out into space. Oh yeah, I can definitely do that.
What happened?
Huh? We got our own magnetic field. Earth has its own magnetic field, which protects us pretty much from almost everything, except for the ECMs, which, like I said, disrupts the communication. But don't worry, if anything big like the sun comes to attack us, you'll be dead before you realize it. So it won't hurt at all.
What if we just like the
It won't change it. So the sun is the center of the solar system. Why?
Because the sun's gravity.
What?
It's mass. 99.8%.
Okay, so where the sun gets its power through nuclear fusion, and y'all know about the nucleus, right? In cells, nuclear fusion. All that is means dealing with the nucleus or nuclei. And what happens is oh yeah, I got my this is a demonstration. Okay, so it's full of what? Who remembers? What's the sun full of? Hydrogen. Okay, so there's a bunch of hydrogen. I got my little pretty pink bunnies here to demonstrate hydrogen. What? This is hydrogen. A little bit, okay. Alright, this is my little. So whenever hydrogen gets close together on Earth, what do you think they do? What is a hydrogen made of? Does anybody know? A proton, neutron, electron? It's a proton, that's right. So the protons are what? Positively or negatively charged? Positively charged, that's right. So when two positively charged objects come together,
They go back up, they move away.
who hasn't played with magnets before? They repel. Yes, thank you. They repel. They hate it. They'll just miss each other. They'll completely avert each other. Because they're both the same charges. It's just their natural nature. They're the same exact thing. They hate. Huh? You can. We actually do it on Earth in nuclear reactors. But it happens all the time, millions of times per second. And the sun's intense gravity and intense heat, they travel so fast they can't avoid each other. Eventually, they collide. And when they collide, it released something. What was it? What did it release?
Water.
Okay, it was two protons. Does protons have mass? Water?
Yeah.
No, it doesn't have water.
They have
Hydrogen. Does hydrogen have water? No, hydrogen's part of water, right? Okay. But it does have what? What is hydrogen? It makes up 92%. Somebody said it.
A gas?
It's mass.
Oh,
It's mass. Okay, right? And when the two protons from the two hydrogens collide and turn into two, they become connected, they lose a little bit of mass. But that mass is converted into energy, and that energy is what fuels the sun. And that's what's been keeping the sun going. And we got about another, I think, 4.5, 5 billion years, and the sun will run out of hydrogen, and it will turn into a, it'll go into a red dwarf. Yeah, it'll turn into a red dwarf, and then it'll eventually compress back together and explode into a supernova. So nuclear fusion is because of the gravity and the heat of the sun. Mostly, a lot of other elements, but mostly hydrogen hit each other and they collide and they emit this small amount of mass. But it makes this intense amount of energy. Recurring questions? Okay, so this is one of my favorite. This is one of the most interesting facts I've ever come across in science. Do you know what this is? So y'all know as it goes this way, the mass gets higher, right? Y'all get an extra proton, right? Keep going line by line. Who knows what that P stands for?
Iron.
Who knows with the significance of the sun why iron's so important?
Because it's heavy. It's like the
It is heavy. So even a lot of these elements, including iron, all these elements are in the sun. They're all gases. There's nothing in the sun that's not a gas
So
because
that's
it's
a
still hot
sulfur?
and so even iron is hot. I've seen iron melted before. I've never seen it as
Even
gas.
carbon too.
Even carbon.
If it's all gases and it takes up to like 6, why is it so heavy?
Yeah, if it's all gases.
Because it's that much mass.
It's just
What?
air.
It's just.
But it's still all
That is
together. That's
compacted.
how much. It's
So if I have air, it's gonna be like heavy.
Yes, air is heavy.
It cannot breathe.
I
Yeah.
cannot feel
I mean,
it.
just whenever think of blowing up a helium balloon. What happens when you have a helium balloon? You let it go.
Why does
And why? Because air is heavy, right?
Air is light, that's why it
Air is light just in this atmosphere. But when you have that much on top of you, water's light, right? Water's pretty light. You get rain all the time, don't hurt you. What happens when you go miles deep into the sea? What happens to you?
You're out air.
You compress. Yeah, you literally get compressed
You
and you
become a
die.
red rocket explode.
Okay, so iron, this is important. Iron, to our knowledge, is the highest element in the periodic table that can be fused in the core of any star, not just our sun, any star. All these can be made in a star. That's it. But we got all these other elements. Most of these other elements, they can be created in a core. Who thinks they know how that's created? Anybody? All these elements are fused together in the sun. They only have hydrogen, and the hydrogen collides, and it collides again, and collides again, and becomes helium. And then helium and hydrogen will combine, and they'll collide. They're adding protons by colliding, right? They're adding protons, but yeah, they do it the same way, but they don't do it in the core of a star. Where does it come from? Okay, so we're carbon-based life form, right? Most of, huh? Atom maker. Okay. So we have all these elements on Earth, right? Who knows how it got here? Okay. For the same reason, the same way all of these elements got here is the same way all these elements were even created. And that was in the explosion of a star. That's the only way. You need a star to explode
What are
to
stars
create